Hello everyone. In the last video we have discussed about the problem and the steps for a problem solving. In that we have discussed what is problem, how the problem is defined, how the problem is analyzed, how we write the code for a problem, how we run the problem. Okay. So now if we want to solve a particular problem, we have a various designing technique to solve that problem or to perform that problem. So in computer science we have various designing techniques to solve a problem. For example, algorithm, flowchart, pseudocode or a program. So these are the designing technique to solve a problem. So today we will discuss one most important designing technique or a problem solving technique, that is algorithm. So algorithm is defined as a step-by-step procedure to solve a particular problem. So what is algorithm? It is a set of instruction or step-by-step procedure. It is a set of instruction designed to perform a specific task. So the word algorithm means a process or a set of rules to be followed in calculations or other problem solving operations. Therefore, algorithm refers to a set of rules or instructions that step by step define a work is to be executed upon in order to get the expected results. Means whatever the instructions we write in a problem, so it define all those instructions step by step. So that is called algorithm. So algorithm is a step by step procedure to solve a particular problem. So this is the definition of a algorithm. Now we will discuss what are the characteristics of an algorithm. So there are 5 characteristics of algorithm. The first one is input, output, definiteness, finiteness and effectiveness. So input. So what is input? Input means feed some data into a program. So feed some data into a program is called a input. So in algorithm it may accept one or more inputs. So to produce something you have to feed something to the program, right? So it may accept one or more inputs. That is one characteristics of algorithm, that is input. Output. Output means to display some data on screen, or it should produce at least one output or a result. So when you say the computer something, okay, it has to process whatever the instruction you give to the computer. So according to your instruction, computer process, right? So whatever we give the instruction in the form of any device, that is input device, that is an input, and what it process and what it gives back to the user, that is a output. So in algorithm it may accept one or more inputs and it must produce at least one output or a result. The third characteristic is definiteness. So definiteness means each and every instruction must be clear, well defined and precise. There should not be any ambiguity. Means whatever the instructions we write in an algorithm or in a problem, each and every instruction must be clear or well defined and precise. Means it must be precisely defined. Precisely means perfectly. There should not be any unclear instructions or any unclear instructions or meaning. Each and every step of an algorithm must be precisely defined or perfectly defined. Means any instruction you are using in the algorithm must be clear. If I say, for example, add 2 and 3, then what would be the result? Add 2 and 3. The result is 2 plus 3 is 5. So the instruction what I have given, that is add 2 and 3, it is correct. Then we can produce the correct result, that is addition of 2 and 3 is 5. Yes, if I say add 2 or 3 to x, then what would be the answer or what would be the result? Here the instruction is not clear, because if you are saying add 2 or 3, or means which number to be added to x, whether add 2 to x or 3 to x. So the instruction is not clear. So such kind of instruction is not given in the algorithm or in the problem. So every instruction must be clear and precisely defined. There should not be any ambiguity. Ambiguity means the instruction must be clear. That is definiteness. Next, finiteness. Finiteness means it should be sequence of finite instructions. That is, it should end after a fixed time. So as we have a finite number of instructions we write in the problem or in the algorithm, everything should be stopped after a fixed amount of time. If you are displaying the numbers, that is 1 to 10, 1 to 100 or 1 to 1000, so after it reached 1000, the process must be stopped. Or if I say, if you are performing something, if you are doing a work, that work should be stopped after some days or after some week, after some month, that work must be stopped, no? So here finiteness, finite or infinite. Finite means there should be fixed time. Infinite means no time, there is no limit to stop. So finiteness means it should be sequence of finite instructions. It should end after a fixed time. Whatever the problem you are solving, whatever the task you are performing, it should stop after some amount of time, after a fixed amount of time. So if I am taking the class, that is online or offline, so my time limit of my class is 1 hour or 2 hour. So after 1 hour, 2 hour, I have to stop. I should not go on and go on. Okay, so for everything there is a time limit. So that is finiteness. It should not be infiniteness. Next is a effectiveness. Effectiveness means the operation must be simple and are carried out in a finite time at one time or more levels of complexity. It means it is the ability to produce the desired result, and it must be possible to perform each step of the algorithm correctly and in a finite amount of time. Means whenever you execute, whenever you perform the task, every time whenever you read the inputs, so every time it shows the correct result. So that is effectiveness. So these are the main important characteristics of algorithm. Input, it may accept one or more inputs. Output, it should produce at least one output. Definiteness, each and every instruction must be clear. Finiteness, it should be stopped after fixed amount of time. And effectiveness, the operation must be simple and carried out in a finite time at one time or a more levels of a complexity. So in general or overall, you can say the algorithm is like a recipe, because it says what must be done step by step. It takes inputs, that is ingredients, and produce the output, that is completed dish, informally. So algorithm can be called a list of steps to prepare a dish. First we take ingredients, that is inputs, and when you start preparing the dish, you taste the dish. Okay, you if it is anything mistake, then you add again the extra ingredients, then finally you prepare that dish, that is the output. So how you prepare a dish step by step. So algorithm also it defined as a step by step procedure to solve a particular problem, to perform a particular problem, that is algorithm. Next, algorithm notations. When you write a algorithm, so here some rules are there or notations that we have to follow. So you can say algorithm is a very basic step to write a program. If you cannot directly write the program, first you have to write algorithm. If you understand algorithm correctly or properly, then only it is easy for you to write any programming language, not only C. So algorithm is a basic step of writing any programming language. So there are some notations. The first notation is name of the algorithm. So name of the algorithm means it specifies the problem to be solved. The problem to be solved, the which algorithm you are going to write. So that is the name of the algorithm. For example, addition of two number, calculate or compute area of circle, area of triangle, to find largest between two numbers, to find simple interest. These are the name of the algorithm. The second notation is step number. So step number means here while writing algorithm you have to specify the step number, means step by step your instruction must be written. So step number, it is an identification tag of an instruction and it is an unsigned positive integer. So while writing step number you have to use the positive integer number, that is step 1, step 2, step 3 and so on.